Alright, Algebra 1, 3.4. We have been moving into the study of lines in Chapter 3. And 3.4, we're going to continue on that journey with slope-intercept form. Okay, so slope-intercept form for lines is probably the most popular thing that you'll see in Algebra 1, Algebra 2, probably what you've already seen in 8th grade. But let's just review it, make sure everyone's super comfortable with slope-intercept form, and we will do a couple of examples together. So here we go. Slope-intercept form is simply the form y equals mx plus b. We call it slope-intercept form because this form tells us something about the slope, which is m represents slope, and it tells us something about the intercept, the y-intercept, which is the b. Don't ask me why they chose b for that guy, but this b value will always be a constant, okay, and m will always be a number. So a lot of times what I see when people learn this is they try to include the x as part of the slope. The x is not part of the slope. M is the slope. Okay, the number out in front of x is the slope. All right, so here we go. Example 1a says write an equation in slope-intercept form and then graph it. So they give us a slope, which is m, and they give us the y-intercept, which is typically b. And let's just make an equation now. So we have y equals the slope, m, negative 1/2, x plus the y-intercept, 3. Okay, this is also known as a b value. This is also known as the m value. Okay, so notice for m, I just plugged in the negative 1/2. For b, I plugged in the 3. Okay, now when I go to graph this, you guys, I always like to start when I know this, when I know what the y-intercept is, it's a nice place to start. So that is at 3. Okay, then from 3, remember what slope is. Slope is just the change in y over the change in x. So in the y direction, we're going to be going 1. And since we have a negative out front, we're going to be going down 1. Okay, so in the y direction, we're going to go down 1. And in the x direction, we're going to go over 2. All right, so down 1 over 2 would put me right there. Now I know that I'm going that direction because from left to right, this thing has to be going downhill. Whenever we have a negative slope, we have a downhill style of line. Okay, so I can continue this pattern on, down 1 over 2, then I can also go up 1, back 2, and I get this line. Don't forget, you guys, I'm seeing in some people's homeworks that they're forgetting to connect the dots and make the line. Make sure you actually make the line. Okay, so that's example 1a. Here's example 1b. It says we have a slope of negative 3, a y-intercept of negative 8. So try this one out. We have y is equal to negative 3x minus 8. Okay, so this one we're going to start at negative 8, and then it's a negative slope. We're going to go down 3 over 1. Remember that this is slope, which is the change in y over the change in x. So if you just have negative 3, it's like negative 3 over 1. So we're going to go down 3 over 1. Because in the y direction, we're going down 3. And then we can also go up 3, back 1. Up 3, back 1. And we get this kind of line. Again, from left to right, it's going down because the slope is negative. Okay, let's try another one. So this one, for example 2, we're going to rewrite this now. So this is in the standard form, and we need to write it into slope-intercept form. So we're just going to solve it for y. Okay, so let me do that over here. We have 3x minus 4y equals 12. Why did I write a 14? I don't know. So let's solve this for y. So first we got to get rid of this x term from both sides, right? Okay, so we're going to subtract 3x from both sides. That goes away. And on our other side, we have negative 3x plus 12. All right, then to get the y by itself, we have to divide by negative 4 because right now it's being multiplied, right? Negative 4 and y are multiplied, so we're going to divide. So we're going to divide everything by negative 4. And for our final answer, we get y is equal to 3/4. Notice the negatives went away because it's a negative divided by a negative, x. And then 12 divided by negative 4 is negative 3. So we have 3/4 x minus 3. That is the slope-intercept form. So I guess I'll write it here on the line. And then they want us to graph this. So there's a couple of ways that we could graph this. We could plug in the zeros like we did in the couple, like a couple lessons ago or last lesson. You can plug in zeros for x, see what the y-intercept is, plug a 0 for y, see what the x-intercept is, and then plot those and connect the dots. Or we can just use slope-intercept form, start at negative 3, and go up 3/4, and then down 3, back 4, and we get this guy. Okay. And then does it want us to, it may want us to, I believe in example 2, what they might want you to do is name the slope and the y-intercept. That's as easy as just identifying these. So the slope 3/4, y-intercept negative 3. All right, let's try 2b out. All right, so let's move our x over for this one. We're going to put it into the correct form here. We get 5y is equal to 2x plus 10. Okay, so then we divide everything by 5 to get y by itself. And we get y is equal to 2/5 x plus 2. Okay, so we're going to start at positive 2. We're going to go up 2/5. And we're going to go down 2/5. And we get this guy. Okay, so that's example 2. Example 3, we have a y equals here. So remember that whenever we have a y equals, it just means that the y value stays the same throughout. So for this case, that y value is at 5. So we're going to have a horizontal line. Okay. For 3, and then if we're going to state the slope and the intercept here, the slope here is simply 0, and the y-intercept is 5. Okay, in case they ask you to list those. If I had a vertical line, remember that if you have an x equals something, it's a vertical line, that slope is undefined. Just so you guys remember that. Let's look at 3b now. So for this one, we're going to solve for y first. So we get y is equal to, divide both sides by 2, 1/2. Okay, so at 1/2, we have the y value that is never changing. So its slope equals 0. Y-intercept is 1/2. There is 3b for you. We have a couple more. Don't know why I skipped example 4, but we're going to move right into example 5. I think example 4 was just a multiple choice problem. So for example 5, we have a real world problem. This is where it really gets kind of fun and application kind of kicks in. So here it says the Band Boosters are selling sandwiches for $5 each. They bought $1,160 in ingredients. Write an equation for the profit made on in sandwiches. So just a reminder here, I wrote it down for you that profit is equal to the charging price times the amount sold minus your expenses. All right, so let's take a look at that. The profit will equal the charging price, $5, times the amount sold. We do not know how many were sold. Okay, so we're supposed to replace that with in. So in amount was sold minus the expenses. Well, we know that, 1,160. And for part B, they want us to graph this. So if I'm going to graph this, notice that the y-intercept is at negative 1160. Okay, so this is going by, this appears to be going by 200. So at negative 1160, we have a y-intercept. then our slope is 5. With this style, you guys, just remember that 5 is the equivalent, is as long as we write something that's equivalent to that, we're okay. So we could also, for our slope, say that we're going to go up 500 over 100. This is the same thing as a slope of 5. 500 divided by 100 is 5. So when we shoot the scale up like this, I like to also, when I'm like figuring out where I'm supposed to be on my graph, instead of trying to figure out where 5 is on this graph, it's easier to figure out where 500 is from where we're at. Okay, so if I go up 500, let's see, that would be here 1, 2, 3, 4, up 500, and then over 100, I'm somewhere in here. And if I do that again, 1, 2, 3, 4, up 500 over 1. It's not right there on the 8, but it's somewhere in here. We get something that looks like this. So that's 5b. Let me just make sure here on this thing that I'm not steering you wrong. I think I am steering you wrong. I apologize, you guys. I just had to look at this again. I apologize. Here. This is a classic mistake, and I'm kind of glad that I just made this in front of you guys. So look, guys, the slope, I guess I can keep that slope there. So 500 over 100. Where I messed up is I didn't look at my scale here very closely when I went to graph this thing. So let's do this again. This thing is going up by 200, right? So I was counting up each one of these as 100. So let's make sure that we go up by 200 here. So if I'm going 500 over 1, that's the same thing here. I'm going to show you another way of doing this. That's the same thing as going up 1,000 over 200. So if I go up 1,000, I would be at negative 160, and then go over 200, and I'm somewhere in there. And then if I go up another 1,000, I would be somewhere in this range. So this is 1,000 here, not quite to 1,000, and then over another 200, and I would be there. There, that line looks better. Okay, so notice, these are equivalent to 5, right? I want to point that out and highlight that again. The reason is, if you do this division out, 500 divided by 100 is 5, or 1,000 divided by 200 is 5. So it's just a way of scaling that slope up for graphs that are a little bit bigger. Okay, for C, it says, find the total profit if 1,400 sandwiches were sold. Okay, so to figure this out, I could just go back now to my profit equation, which we already did in part A. I think this is 1160. And then I'm going to take my number of sandwiches and plug it in. So P is equal to 5 times 1,400 minus 1160. And then if you could do this on your calculator, you could do it out by hand, it doesn't really matter. But when you do this, you should get 7,000 minus 1160, which is equal to $5,840. Okay, so there's your profit on this one. That's it for this time, guys. The homework, there will be a homework sheet for you, so don't worry about this. And we'll catch you guys in class.